Today's presentation, we're going to show you a solution that we have deployed at most of our clients. And we're busy, like Oracle, busy productizing artificial intelligence solution around documents. There's a lot of really valuable data that's trapped in documents, and we want to untrap that. And it's important to think about it as we call it artificial assistance. It's not going to make decisions for you. It's simply going to take the mundane work of data entry and analysis away from you, or you don't have to do it. So a little bit about me. I've been working with Oracle since the late 90s or since the mid 90s. I started using Apex early 2000s when it was still HTML-DB. I use it. It's our go-to application at Viscosity. And over the years, I've been a DBA, I've been an e-business suite functional project manager, I've been a developer, and just really stayed within the Oracle ecosystem, and with also really cool technology, just very much an enthusiast. So I do a lot with business applications. So I'm interested in solving business problems. So some of the problems that we have with documents are, we need to read the document, extract the details, analyze it, and then key that into some sort of system. Sometimes we don't do that at all. We leave it in paper. Sometimes we key only some information, like you can think of an AP process where they only key the invoice amount and not all the details because those things are long. And this creates a lot of unseen risks where we don't have actionable data in our systems. All of our decisions are delayed. We lose data along the way. We lose fidelity along the way. And you get things like all this data trapped in Iron Mountain that just hasn't been entered. And then also, when you talk about documents, you're usually talking about business processes and workflows. And those are very specific to each person's business. So out-of-the-box type solutions don't work. They almost never work. If you've been through an ERP implementation, you'll know what I mean. Those things never finish. They run way over budget, and they deliver very fractionally on what they promised. So some of the documents, right, we kind of categorize these into unstructured, semi-structured, and data, for example. So data in a database, that might be, we could extract that with JSON, XML, or even CSV. That's more of a structured type data. Semi-structured are digital documents that have already been digitized. Maybe some OCR has been run on them. Maybe they're digital native documents. And then unstructured documents are just pictures of things. They can be pictures of images. They can be pictures of tables. They could be scans like we'll scan today. And then those things can come through a variety of sources. And what we try to do is take the friction out of it. So if you've got a Dropbox, you can link it to our solution. If you've got cloud storage on Oracle Cloud or AWS buckets, you can link that. If you've got a smartphone, you can take a picture of a document. We'll turn it into a scanned image and extract the data from it. And then, of course, legacy databases that have some of the information but may be incomplete and need to be joined up to the source transactions that are in these documents. So the solution that we approach is a three-pronged approach, right? We want to ingest the document, do optical character recognition, but that's not enough because some of these documents are really old. Some of them have handwriting on them. Some of them are only in handwriting. Some of them have images on them, right? So we need to do intelligent character recognition, and I'll show you some of that today. We also want to classify the document. We call this portion of our solution the document lake. Let's get the document into the system without any friction. Let's get the data highly accurately scanned with intelligent character recognition, which is far superior than what you might be familiar with OCR, and get that document into the system and classify it. Once we've classified the document, we can route it. And so that's this area here we call the knowledge layer. We want to route that document and extract the data from that document once we know what type of document it is. So we want to get the unstructured data in the document, extract it, and then we want to put it in front of a subject matter expert, a financial analyst, a lawyer, a paralegal, a business analyst, somebody in the AP department, anything like that. We want to have them refine the understanding of that document and the group of documents. We also want to relate that document to every other document that might be. So for example, if you have a customer contract and you have an invoice that goes to the customer, those documents should be related. And then we also want to enrich the document, the data that's in the document. We may have some information in a legacy database that needs to be joined up to that document. Or we may need to crawl the internet to find a product catalog and the current pricing off of a vendor's catalog list. And then finally, we want to take action on that information that we've gathered. So we want to kick off a workflow. We want to send an email. We want to trigger an API. We want to enter the data into a CRM system. We want to enter the data into our ERP system, our accounting system, right? And this is, in the realm of robotic process automation. In fact, we use robotic process automation. We use Apex as our exclusive hub for robotic process automation. So what does it look like? It's documents to data in seconds at a speed that's faster than humans and an accuracy that rivals humans. So here I've got an AP invoice, a very simple transactional document. We'll do more complicated documents than this. And then I've got the data represented in JSON. And so I can control the AI to extract that data in a normalized way. I can also feed it a list of known values that I want to normalize it. So if you called it potato and I call it potato, we can make that happen, right? So also, people, when they enter data into ERP systems, a lot of times we get duplication of vendors. We got 10 different Amazons, 20 different Grangers. So these are the kinds of things that we can do with that document. So let me show you a little example here, and I'm going to switch to my phone. Can I share from here? That way you can see the camera. Share screen. Start. And I don't know that it's going to show on Zoom. Oh shoot. All right, I'm getting a little out of my realm. Well, I'll just tell you, I've got a receipt from FedEx. Okay. So I'm going to drop it into this scanner. This is a standalone scanner. It's not connected to any computer. And it runs an Android operating system. We have our code on this. So I'm going to select to send to the cloud and scan that document. And that's going to take an image and send it through a series of steps, which includes the intelligent character recognition, and then sends it to some sort of an AI. And we'll talk about the different AIs that we can plug into. And then the document will show up in our document AI. So if I go to this guy. So this is the one that I just scanned. And let me take some of the goofy stuff off of here. Okay. So let's give it a second. Well, I've got another receipt here. So let me pull that one up. Oh, I'm not sharing. Am I sharing that screen? All right. Well, I think I bogged the computer down. Demo gods are not fair today. I'll give that thing a second here. But we'll come back to that. But basically, documents to data, and then we'll send it to a knowledge layer. So some of the key features of what we're trying to accomplish are, very simple document insight. We're trying to, with a very low touch, get as much information out of the business analysts and the people that know how to interpret these. We're trying to do as much work for them in advance so that they can just correct. They're humans in the loop and they can kind of correct what we're looking at. Some of the use cases are contract review or other industry specific type understanding of documents. We want to be efficient and we want to have an intuitive design so that you can just simply be oriented to this solution. And the document AI is usually, it's at the lowest level. So getting a document ingested, extracted into a workflow and start to build knowledge about it, that's a very low level function that we would do typically on the initial engagement. And then after that, we'll build either on top of that an application in Apex, robotic process automation, some kind of workflow or email alert, an API, an ETL, an insert into your ERP, that kind of thing. So some of the use cases that we can show today, if that thing works better, is transactional documents like the receipt, like an AP invoice, like a purchase order, or a packing slip that may come on the receipt of a purchase order. HR documents. I've got Elizabeth's resume that I'm going to load here in a second, so you'll see it. Real estate records, such as your title to your home, your title to your land, warranty deeds. If you have an oil and gas lease or a right-of-way for a windmill on your property. And then also one of the things that we've got a lot of traction in is kind of a private equity mergers and acquisitions due diligence. So kind of accelerating the process for companies to acquire or divest. So we really take it through, we talked about the 3 stages. These are really the 6 finer stages, right? So ingest, categorization, extraction, where we're taking out attribute value pairs, tabular data, enrichment, by we're relating it to other transactional data in our source systems, the understanding layer, and the action layer. So let's go back to the demo and see if he's come back. Okay, there we go. So this document is a receipt. And there we go. And so what we've done is the AI has extracted, without ever seeing this kind of receipt before, it's extracted this type of data from it, right? So it's a Starbucks cold brew go-go smoothie. I think Monica ordered this one when we were at Odin Tug. I don't see Facebook. So that would happen in the transactional system. Yes, sir. And you can see that this data has been extracted. This is what it looks like to the computer. This is the history of the action. Now, this is very generic information. It just kind of gives me a generic dump of what it thinks is important. But I might be more interested in, a compliance issue. So I'm not going to approve, was any alcohol? alcohol purchased. Did it exceed $25 for a meal? Right. So I can add these insights as I start to understand these documents, and I can add them at a category level for all receipts, or I can add them at an individual document level. So I can just do this ad hoc, or I can memorize it here and start to build up my policies and how I want to extract the data. And I'm sorry how slow this is. It wasn't slow when I wasn't sharing. But we'll see. So as I build these insights to the document, this is something that an expert user would be, whether that's an AP manager, accounts payable manager, or a paralegal, or somebody that has domain expertise. And they can build these insights up, and then those things get remembered. It's going to be pretty slow today. So what does this look like from an architecture standpoint? You've got your on-premise and third-party systems that you're interested in. So we have an agent that goes there. This says EBS, but it could be really any system. You have Viscosity AI. You have our large language models here, which are private, or you have wrappers for public large language models. And then you have your tenancy, which includes a database, your choice, Oracle Apex and Oracle Cloud Storage. We also have the ability to move into your tenancy any of this processing power. We usually use the Oracle Container Cloud to do that. It's a very easy way for us to deploy a redundant workload without having to stand up a physical server that needs to be maintained so much. So how does the document go? The document starts here. We're ingesting the document. This ought to look familiar if you've done any data warehousing, right? So we have we call it the data hub. We have a staging area where you stage relational raw data. We have an operational data store where you make your own model about that. So you have multiple systems come in the staging area. You have an operational data store. And then you have relational summarized data, very familiar stuff. Up here, you have what we call data apps. These are Apex apps that are made for a particular job function, line of business, anything that you do. We also have other apps that we can instrument and target. So down here is really what we're providing. Have a document lake, so we can store any kind of document, whether that's unstructured, semi-structured. We can take paper from the scanner. We can ingest that paper. We can take reams of paper and categorize and split those documents out. And then we have a JSON representation of the data. What does JSON buy us? It buys us the ability to store data without having to predefine the schemes, right? So we can say to the AI, hey, give me what you think is important in this kind of document. I've never seen a document like this before, right? So maybe it's I don't know, a bull purchase agreement. So I've never bought a bull before. I've never seen what that looks like. So it spits out the JSON for me, and I can store it here. Usually we store that in a graph database because graph gives us the ability to traverse JSON and to kind of build connections there where we don't, the graph database emphasizes the relationship among the data. And then we use like a natural language processing so that we can understand semantics. So we know that red is equal to fuchsia, is equal to rojo, is equal to, any language, right? And then finally, you heard a little bit about the vector database. We store this data in a native vector database. And what that gives us is the ability to say, hey, if it's food or if it's a taco is very closely related to food. So it gives us that understanding and that knowledge layer. So we can search for, give me all the food, give me anything related to food, and it can go through and search that. It's important that that's native in the database, because you can store vectors in any relational database, but you got to pull the vectors out, send them to a program, iterate through every vector, and then put them back into the database, or get your answer that way. It's very slow to do that. So a native vector database is very important, because we can do that right in SQL, for example. Or if we have a graph query language, usually is what we use here. Some vector databases are, the most popular is PineCone-DB. We've used it. Craig's used it. We also use WeAviate. WeAviate gives us the JSON and graph, and it also gives us a semantic layer that Pinecone doesn't have, but it's not as popular. And this is where all the extraction happens. We get it into the relational database so that we can build structured applications on top of this unstructured data. So another live demo. we'll see how it goes. I've got Elizabeth's resume, and let's just hypothetically, she's attending a career fair. So we want to basically have a mobile app in Apex, take a picture of the resume, quickly ingest it into our HR recruiting system, intelligently extract the resume data, create a candidate profile associated with all the jobs that are there, and do all this in an automated fashion without manual intervention. Let's try that. So again, you saw the low-level document AI, and that was here. It still hasn't come back. Okay. So let's do, let's go over the demo system. That's this guy. And so what we'll do here is I'll bring it into an Apex application that sits on top of that stack called Recruit AI. And so what I'm going to do here is go to candidates, and I'm going to upload a resume. Let me show that to you first. Let's see. Here. There. So I just pulled Elizabeth's resume off of LinkedIn. We'll see if she's telling the truth. All right. So in this case, I've just uploaded the document. This could be part of a, it could be hooked up to the scanner, or I could have taken a picture from the phone. So I've uploaded her resume. And while I'm doing that, let's say I'm working with a hiring manager that wants to hire a solutions architect. So I'll come over here and I'll say solutions architect. And Albuquerque. Did I do that right? High school? That's hard. I got nervous there. And we'll... Yeah, I got that whole vibe, man. Just they really captured the city on that show. And then, just I don't have to put a description here. I can just say, write this for me now. But I'll say, hey, we want solid Apex experience, 5+ years Apex experience, Oracle database. Let's make sure this is Oracle, so it's not Salesforce Apex. Oracle database, management skills, and work ethic. Anything else I should put on there? And then I can say, write this for me. Okay. And so it has the AI. The AI, in this case, the AI can help the hiring manager, because let's face it, if you've ever had to hire anybody, nobody wants to do that, right? It's like, I just want to get done with this. Let's hire somebody who's decent so I can get back to my regular job, right? So we're coaching the hiring manager to create to create good job descriptions that have a lot of, I don't know what's happening there. We'll demo it over at our table here. We can go through all that. But let's see. Let's come back to the candidate. So out of the candidate, I've preloaded Elizabeth here. Where is she? There we are. So what we've done here is we try to normalize the data because people's resumes can look all kinds of ways, right? They can have their picture on it. They can have 15, 20 pages. They can have one page, right? We just want to see what their continuous employment is, any specific skills that they've identified. LinkedIn is not a great resume producer, right? And then any matching jobs that they're against. We also want to say, what the summary of this candidate is. And then that way we can go through and we can look at hundreds of resumes in kind of a normalized way. So that's basically an application of that piece. And we'll disconnect from Zoom and see how that goes. In fact, yep. So then, what am I doing on time? So really, this last piece, right, is that app is like taking action on the document AI. So we can do this at an employee level, at a department level, HR, or at your entire corporate level. By observing all the inputs into a business process, user interfaces, if you've got third-party systems, spreadsheets, documents, other systems interfaces, and all the outputs, right? Which is having an app to track the data, being able to send out reporting to trigger events. So inputs and outputs, right? We have inputs to our analysis, and then we have summaries that we output. And so by observing all the inputs and outputs, and here's some of the methods that we can tie it into. So we've got interfaces to email, so we can read inbound email, process it with AI. We can read postal mail. Lock boxes can have robotics to open the letters. We can send letters out through postal mail. We can send outbound emails, and we can take any document in or out. By orienting our solution around this, and by capturing and helping each one of these people in the department, we can eliminate some of the mundane work there, freeing that employee up to do higher value work. Here's kind of an interaction diagram of a finance use case. So you've got customers here on the top, you've got suppliers, employees, your banks, and your subsidiary companies or other trading partners. So you might have your customers may send you a purchase order, you send them a sales order or a receipt. Then you send them an AR invoice, you want to get paid for your work, and they send you a check or an ACH transaction. Similarly, on your supplier side, you may send them a purchase order, you may not. They may send you a sales order or receipt. They may just send you the goods, a packing list, for example. They'll send you an AP invoice for sure, because they'll want their money, and you send them a check or an ACH. And every year you might collect a new W-9 or other IRS form, tax exemption form, something like that. Similarly with employees, they have expenses. You're logging receipts. If you're traveling today, you want to log your receipts so you can get reimbursed for that. And you're sending in W-2s or W-4s for your options. Your banks likely your bank will have a bank statement. You may have a complex integration with your bank, but if you have just a piece of paper, you can read it into the system with AI. You have a credit card statement. An employee could have a credit card statement, or you might have a procurement card for the whole company. And then you have maybe a payroll provider like Paychecks that does your employee payroll. And then, of course, you have financial statements coming in or out from your subsidiaries. So it's a very complex process. It's very manually intensive. And so what we could use AI to process how we would approach this problem, which is a bit more complex, is, we see it as, money in and money out. I've got receipts, bills, POs, and checks coming in, and I've got receipts, bills, POs, checks going out. I've got, my financial system. I'm doing data enrichment with AI, and I'm reconciling these transactions, and I want to put it into buckets. What are buckets? Well, we have concept of transactional buckets, so like AP, AR, or banking transactions, and we also have master data buckets. So maybe it's a supplier who I've never dealt with before. So I want to be able to extract that information from the document, kick off an enrichment cycle, and get that master data defined. Because if you've ever used like Oracle EBS or Fusion or NetSuite, you can't enter the transaction until you've created the supplier, right? And there may be some workflow around that, some checks and balances, some third-party systems that we have to connect to, right? Same thing with customers. We want to do a credit check on the customers. If you're purchasing inventory items, you have your purchase items that you're buying and the ones that you're selling. Other employees need to be defined when they're onboarded, for example. So that's kind of a conceptual way that we bucketize this data and organize it so that it can go into a transactional system. Let's take a look at Elizabeth's resume and see if it came back. Okay, so we got Elizabeth's resume, and yep. So when we look at this, we've been working on this for about 5 years. We started with what we call supervised machine learning. That's where we take hundreds or thousands of documents, and we have humans go in there and say, oh, that's where the PO number is, that's the invoice number, except when it says this, and they kind of correct and do supervised learning. And we also built some expert models, right? Expert model means it only does images. So we take the PDF file or the document and pull out just the images and do some kind of recognition on the image. These are all human in the loop. With these large language models like ChatGPT, the P stands for pre-trained. So they've already been pre-trained on pretty much scraping the entire web, right? And other things. So this is a lot less, this is a very tedious way to do it, even though it does automate things. This is so much better. This has changed a lot of things for us. Anthropic is a very good one as well. They have a huge window size, so you can deal with large documents there. You can't do War and Peace yet, but we have a technique to do extraction, which is a unique problem. Chatting with a document is one thing, but doing a complete understanding of the document, that's a totally different problem. And people are spending a lot of money on that. They're building wafer scale computers to do it. And then we have these private foundation models, like you mentioned, Oracle has chosen Cohere for that. There's a new model out. Llama was the big model. We had very small, 2 billion parameters, 10 billion parameters, 8 billion parameters, 30 billion parameter llamas. This was released by Facebook a few years ago. This Falcon 180 is the newest one. That's probably the hottest one. Now, when you take one of these models, the good news is it's open source, it's private to you. So you're not sending your personal data, your company data to a public large language model. I don't know if you guys saw the issue with Samsung, or that the guy shared the data and they wanted to get it back, and they said, well, we can't get your data back, it's already in the machine. I know Larry at Oracle put a halt on all AI for a while until they could figure out what they wanted to do. They said no using AI in your function. And then we've got our expert models, which are they do very specific things, like maybe analyze financial transactions, look at images, make other kinds of determination that are not kind of general. And for that, a good place to start is Hugging Face. This is a really cool solution. You go out there for nothing and spin up some of these models and play with them. Has anybody played with ChatGPT? Everybody? A little bit. I use it a lot. Anthropic, great interfaces in it. And if you use Bing and other search engines, you're using the AI anyway. I like how it kind of cuts down on what you have to look. You don't have to look it through somebody's search engine optimized advertising BS. And you can just kind of cut through to what you want to know. We mentioned some variations on this as we get more complicated. This is a document from 1963. It describes a piece of land, south 8952 west along the south boundary line of Walker land, then along the east boundary line, and then we grant and we reserve 1/2 of all the oil and gas and other minerals on that tract of land. Blah, 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 blah. We've got speckles on it. It's crooked. It was on microfiche. It's hard to read. It was a typewriter. Sometimes here they typed a 1 and they just overtyped a 2, or they typed a 2 and they overtyped a 1. Who knows, right? So those are the kinds of things we're trying to solve. What's cool is we created what we call a flywheel, where we can do an initial OCR on this, then feed it to a large language model that understands this type of document. And so it can understand the character within the word. So you've already beat OCR, right? OCR just looks at that character and it's like, oh, is that an N, or is it a U, or is it an O, or is it an A? It might be an A. But with large language models, since they understand the letter within the word within the sentence and the paragraph, and the paragraph within the context of that document, and that document within the context of thousands of other documents. So they can do a lot of corrective stuff for us, and that's what we use for some of these oil and gas use cases. So let me show you an example of how you can build your own wrapper for an AI model. In this case, we'll just use ChatGPT, and I'll show you our Apex app here. And that's really the first step, is to wrap up an API. So let me go into the demo system. So you can see these, all of our applications are connected. So when I input that job description, it went here. It might have come back. So let me go over. Actually, I closed that out. But it came out and it said, hey, these are the skills that you'll want to have. Right. So that's what you would have seen in the application itself. Let me show that again. And we have a unique problem that comes in. We call it the window size. You can't take the entire novel of War and Peace and send it to ChatGPT. It'll blow up. It says, so I can only handle 4,000 tokens or 8,000 tokens or 16,000 tokens. And tokens are kind of like words, right? But they're basically the nodes in the just to simplify it, they're nodes in the neural net. So in this case, I had okay, there we go. So if you read this prompt, and this is an area in AI, they call it prompt engineering. It's structuring these prompts and learning how to coax information out of the AI is really important. So your language, your programming language is English or whatever your natural language is. So you're an oil, gas, and renewables land title attorney, and you'll extract the following normalized structure, which I define here. So I use JSON. I'm telling it I want JSON in this format, and I want it consistent. So since the lease document is big, I'll feed you pieces at a time, pages at a time. And you'll keep my same JSON structure after each piece. But you'll replace my attribute values only if you find a better answer. Otherwise, leave them blank or keep the previous piece's value. So I'm telling it to constantly refine until you've iterated through the whole document and you found a better answer. And that's how we get around some of the window sizing issues. And so the AI gave me, this back. So it extracted from that document that we looked at, bonus payments, royalty rates, rental payments. I told it I was very interested in these kind of clauses because these kind of clauses they affect the operator's the value of the lease. This is part of the due diligence for the equity companies that back these operations. And it pulled out all the other stuff. It even pulled out who was the notary and all that good stuff. So the way this works, I'll go into this, is just an Apex app. And you can see here, these are all the parameters that you would send to OpenAI. So in this case, you can pick the model. We'll pick this guy. It's fast and cheap. You can put the maximum tokens that you want to send because your window size is basically all the ones that go in and come out. So if you are asking for a big, long answer, you may not want to send too much to it. Temperature, that tells it how creative it needs to be. 0 means it's very deterministic. That means you get the same answer every time. 50% or 100%. 100% means it can do a lot of, get very creative. It can start talking to you about Mickey Mouse or something, right? And then some other parameters. So all these are just Apex regions. And you can type any question you want here and send it. So how does that work? So let me go to page 110 and let's kind of look at how this is structured. Okay, let's go back in. Let me try this again. Sorry, guys. Batting the thousands a day. So it's blocking me from the builder here. Let me go. That was page 110, I think. Okay. Yeah. Third time's the charm, like my grandma always said. All right. So we'll go into this app. We'll look at page 110. That's kind of the page that we started with. That's kind of where the magic happens. So open this guy up. And we put a dynamic action on this button, submit. So that submit button. So let's take a look at the JavaScript code there. Just a little bit of JavaScript. So the first thing I do is I pull the values out of those fields that you saw so I can send them to the model. And once they hit the button, I'm going to go ahead and disable the button so we don't get people real, excited and keep pushing the button over and over again, right? And then I'm going to call this page process and pass it the page items. Okay, so I'll show you that page process in a minute. And then I'm going to register an AJAX call. And when that AJAX call comes back in the background, it's going to fill out the result that's coming from OpenAI. I'm going to go ahead and enable the button again. And then I'm going to catch the errors if there's any. So let's take a look at the page process. Has anybody done Apex page processes? Yep. Okay. So let's take a look at get chat completion. Not a lot going on here. It's just the Apex page items that are getting pushed over AJAX to this PL SQL process. Okay, so OpenAI.apex get chat completion. So let me just copy that. And then that will be defined in, let's just go into object browser. And okay, so let's just take a look at this PL SQL process. So the same page items, they're coming in through here. We set up some objects like our JSON going out, for example. We basically created an array, and we make a call to OpenAI chat completion. We'll insert that into our API requests. And then we package up the message, parse it out with JSON, and send it back through AJAX. So really just 3 pieces of code, a lot of debugging and testing, but nothing too hard. You can build your own wrapper for ChatGPT. You can even ask ChatGPT to help you with this kind of code creation. So it knows how to do its own API. So it doesn't do PL SQL that well. It does Python really well. So, and I think that's the main thing I wanted to show you. I have some other use cases. We're coming up on time. One of them was private equity due diligence. Another one was that oil and gas lease extraction, or understanding who's the true owner of the land and the minerals. And I guess we can revisit anything or talk about some questions if anybody has any questions. If you don't have any questions, I have questions for you. We're just looking for problems to solve, right? We want to solution things. There's things that we don't know. We want to walk processes and understand, where you're having your pain, where your opportunities, do you think your opportunities lie? I talked to a guy on the plane ride over here. His problem is quality control. And there's nobody that's there to check the quality on receipt of inbound goods. They make this plastic for roads, so the plastic paint that goes on the road stripes. They also make the cutouts for like turn lanes and things like that. And they don't know that they have a problem until they're melting it out on site and it's not sticking. So he needs a solution to help quality control. He also has, a problem with labor. So he needs a solution around that. And we talked to the private equity companies. They need to be able to analyze massive document sets very quickly. Where else? Any questions, any ideas? We can always talk afterwards. And that's about it. Just a little bit about Viscosity. We do business transformation, about 75 certified consultants. We do data, apps, and cloud. We've written 30 books on Oracle and other business applications and systems. These are some of them. We got Craig, one of our esteemed authors, and we work with every kind of business, anywhere from mom and pop shops all the way to nonprofits, all the way up to the Fortune 50. That's all I got.